Okay, so today what we're going to do is we're going to do a couple of these little videos. I'm going to try to make them a couple minutes long so we don't have to worry too much about them, or focus too long on them, rather. The first one we're going to do is the one that has a circle and a point A and a point B. Okay? Now, if it's going, there's an object that is being slung in the circle, okay, and it's right here, we'll say. This object has a mass of, we'll say, 2 kilograms, and it's got a radius of 3 meters. Okay, so I'm slinging this thing in a circle, and it's a vertical circle, so vertical circle. And what I'm wanting to know is if this is the string right here, what is the tension in the string at point A and point B? So I want to know the tension in the string at point A and the tension in the string at point B. Okay, so let's say that this circle takes a grand total of 2 seconds to make a loop. Well, if we look at our problem here, essentially we're trying to find the tension, but the tension is not the only force acting on this. It should be obvious to you that if I'm swinging it in a vertical circle, that at both of these points we not only have a tension, we also have a force of gravity pulling down. Alright? At this point we have a force of gravity pulling down and a tension pulling up. So the tension is not alone, so we can't just plug it in as centripetal force. The second thing we have to recognize is that the centripetal force is equal to the net force on the object. So what we have to do then is say that, first of all, find the centripetal force. So let's do that first. Centripetal force is equal to mv squared divided by r. But, unfortunately, I don't have a v, so I've got to find that. Well, v, if it goes in a complete circle, v will be equal to 2 pi r times the amount of time it took to make the complete circle. So, in this case, v is equal to 2 pi times 3 divided by 2, and we would get 9.4 is our velocity. 9.4 meters per second. So now I'm going to come back up and plug that in here. Fc is equal to mass of the thing, which was 2 kilograms, times 9.4 divided by 3 meters, which is our radius. Okay, so 2 times 9.4 squared divided by 3 is 58.9. So the centripetal force is equal to 58.9 newtons. Okay, so we found the centripetal force is 58.9 newtons. Now we need to move on. So here we go. This is our basic setup. We have two forces acting at both points. We know that the centripetal force is equal to the net force. So therefore, I know that the centripetal force at the top is equal to the tension minus the force of gravity. Or sorry, that's not right. The tension plus the force of gravity. Because what we do at the top is we say that since the tension and the force of gravity are both acting down, we'll just make up at point A, down is going to be the positive direction, so we don't have to worry about negatives. And we can solve for this because we know the centripetal force, and real quick, if the thing has a mass of 2 kilograms, the force of gravity should be 20 newtons because force is equal to mass times 10. So again, the mass was 2 kilograms, 2 times 10 is 20 newtons for our force of gravity. So on this first one, we have 58.9 equals T plus 20. Subtract 20 over the other side, and we get 38.9 newtons equals T. For the second one, you should be fairly easy to see. Same thing, F net. We then need to know that the centripetal force is equal to tension minus the force of gravity in this case, because since tension is going up, we have to direct up as our positive direction. Force of gravity is acting against the tension, so when we fill this in, 58.9 equals T minus the force of gravity, which is 20. Add 20 to the other side, and we get 78.9 newtons equals T. Alright, So this is how we do that problem, and I hope y'all have a good day.